Hello students, in this video I will demonstrate how to graph the cotangent function. If you're given a cotangent function f of x is equal to 2 cotangent x over 2 minus pi over 4, we want to graph this function. So let's begin by finding the period, the stretch or shrink factor, the horizontal shift, the vertical shift, and the equation of the asymptotes. Alright, so we know that cotangent is basically 1 over tangent. That is the first thing you should keep in mind. Since cotangent doesn't have a maximum or minimum, we're going to name the amplitude the stretch factor or a shrinking factor. In this case, I see immediately that the stretch factor is 2. Let me just put my ABCs here. So A, B, C, and D is 0. The period I know for cotangent, the period is pi over B. So this is going to be pi divided by b is 1/2. So this is 2 pi. Okay, so the period length is 2 pi. The horizontal shift is c over b, which is equal in this case pi over 4 divided by 1/2, or you can say this is pi over 4 times 2, which will give you pi over 2. So we know that the graph of this cotangent moved to the right pi over 2 units. The vertical shift is non-existent. We don't have a vertical shift since d is equal to 0. Now before I dive in and find the asymptotes, let me try to make sense of what I'm doing here, and let me try to find the 5 important points for the graph. So I will take the period divided by 4. I will have 2 pi over 4. That will make pi over 2, and I'm going to say 0, and then pi over 2 plus pi over 2 is pi, and then pi plus pi over 2 is 3 pi over 2, and then 4 pi over 2 is 2 pi. So I'm just going to stop at 2 pi here because that is the length of the period. So those are the important points. And notice that we have a horizontal shift, which is adding pi over 2 to these important points. So I can choose to do it here, or I can just draw my new y-axis and then put the original points. If I want to add the horizontal shift here, I can, which is going to give me pi over 2, 3 pi over 2, 2 pi, and 5 pi over 2. Okay, now I might not need to do that. I'm just going to focus on the original points, and then I'm going to plot the horizontal shift, and then put the points on the new x-axis. So if I put my points in here on the original axis, I'll have 0, pi over 2, pi over 2, pi, 3 pi over 2, and then 2 pi. Okay. I'm going to add 5 pi over 2 here, just because I have the shift. All right. Now, to find the asymptotes, the vertical asymptotes, I know that tangent has a vertical asymptote at 0, which means that cotangent doesn't have that. But I know that cotangent is also equal to cosine over sine, meaning if sine, the angle, is equal to 0, it means we're going to have an asymptote at that point. So if you look at the unit circle, you will notice that sine is equal to 0 at 0, and it's equal to 0 at pi, which means cotangent is going to have an asymptote when the value inside of the argument of the cotangent is equal to 0, or it is equal to pi. Right. So let's go back here, and let's make the argument inside of the cotangent equals to 0 once, and then pi once. So here Here's the argument. I'm going to do it here. So x over 2 minus pi over 4 equals to 0. And then if I solve for 0, I'm going to multiply everything by 4. I will get 2x minus pi equals 0, which will give me 2x is equal to pi, or x is equal to pi over 2. And this is my first asymptote. And then I will put the argument again equals to pi and find the other asymptote. Or I can simply add the period length, and that is going to give me the second asymptote instead of going to the length of solving two equations. But I will do it both ways. So x over 2 minus pi over 4 equals pi, which is going to be equal to x. I'll multiply everything by 4. 2x minus pi equals 4 pi. 2x equals 5 pi. X is equal 5 pi over 2. Okay, so here is my second asymptote. I could have just found one, and then the other one is going to be just adding one period length, which happens here to be 2 pi to the first asymptote to find the other asymptote. So I can clearly see that this line right here, which is exactly the horizontal shift, is going to be one of the asymptotes, and the other one is going to be another asymptote here. All right. Now, I know that in the middle point, 3 pi over 2, I know that cotangent is going to be equal to 0. Let me prove it. So here we have cotangent of when x is equal to 3 pi over 2. So it's going to be 3 pi over 2, which is 4, minus pi over 4 equals 2 cotangent. So what I did here, I took x out and I plugged 3 pi over 2 instead of x. So here is when x is equal to 3 pi over 2. Okay, cotangent 2 pi over 4, which is pi over 2. And I know that cotangent pi over 4, pi over 2. Okay, let's go to pi over 2. I know that sine is 1 and cosine is 0, so it's going to be 0 over 1, which is going to be 0. Okay, so cotangent at that point is going to be 0 because cotangent is cosine over sine. All right, so this value is going to be 2 times 0, which is going to be 0. So here is the first 0. I know now that at pi, when I plug x is equal to pi, the value of the function is going to be positive 2, and I can prove it, 2 cotangent. Let me remove x and plug pi instead, so it's going to be pi over 2 minus pi over 4. The original one is 2 cotangent x over 2 minus pi over 4. So that is the original function I'm working with. Equals 2 cotangent pi over 4. And if you go to pi over 4 and find the cotangent on the unit circle, here is the cotangent, which is cosine over sine. That's 1. So the answer here is going to be 2 times 1, which is going to be 2. So it's going to be 2. Let's say this is 1, this is 2. So here is the 2 value. And then when x is equal to 2 pi, I know the value is going to be negative 2. 2 times cotangent of 2 pi over 2 minus pi over 4 is equal to 2 cotangent of pi minus pi over 4 is 3 pi over 4. So if I go to the unit circle and find cotangent 3 pi over 4, it is negative 1. As you can see here, it's equal to negative 1, which means this is going to be equal to, here is when x is equal to pi, and here is x is equal to 2 pi. Okay, 2 times negative 1, which is negative 2. So the value here is going to be negative 2, here is negative 1, and here is negative 2. Okay, now if you want to graph the cotangent function, it's going to look something like this. And that's basically how you graph these functions. Again, I'm going to go back to the asymptote. So the asymptotes, I computed only 2. So I can say those are x is equal to pi over 2, and then 5 pi over 2. So basically it's plus multiples of pi, 2 pi, sorry, such that k is an integer. And that is how you find these asymptotes. So pi over 2, and then we know we add the length of the period, just happens to be 2 pi here. So multiples of 2 pi, this is how we write it, 2k pi or 2 pi k. K is an integer. So this is how you're going to graph the cotangent function. Is y equals negative 2 tangent x over 2 minus pi over 4 a correct way to rewrite f of x, explain why or why not? It is not, because tangent has a different asymptotes from cotangent. We know that tangent is sine over cosine, and cosine is equal to 0 at 0 and pi. So that is going to produce, tangent is going to be undefined when cosine is equal to 0, and that is going to happen at pi over 2 and 3 pi over 2. So to find the asymptotes for this function, we have to make x over 2 minus pi over 4 equals 1 to pi over 2, and then we can add the period length, which happens to be the same. It's 2 pi, it's the same. But now if we solve this, we're going to end up with different asymptotes than the ones we did before. Multiply everything by 4, you get 2x minus pi equals 2 pi, which is 2x equals 3 pi, and x is equal to 3 pi over 2. So now the asymptote is exactly the 0 point for the cotangent, and that's why we can't say that, because the tangent has a different asymptote from the cotangent. You can find the rest of the asymptotes by adding multiple of period length, which happen to be the same. So 2k pi, and k is an integer. This is basically it.